Right. Good evening. I'm Mrs. Kritika. I'll be handling computer papers for you all. So, as we are starting with the beginning of the class, I wanted everyone to know the basics of the hardware and also the software. Anyway, we'll be dealing with the software and basics of hardware too. Not in very detail, but very important hardwares which we are using in the computer should be known before learning the computer programming language. Input and how the process is taking place and the output. We'll be dealing with the memory. So, what is the work of CPU? That is the central processing unit, and the different types of software, and some real life examples. So, unit, and next we have control unit, and also you will be able to differentiate between the hardware, and the very important concept is the difference between the system software and the application software. Next, you will be able to connect life situations too, right? Next, the basic question: what is the computer system? So, as you all know,
Excuse me,
when we
ma'am.
combine the some
Ma'am, your screen is not visible.
sorry,
Screen is not visible.
is it not visible?
No.
1 minute. Hope it's visible now.
It is okay, but I believe there is some network issue. Call is
Yes,
breaking
ma'am.
again and
Your
again.
voice is not visible, not clear.
Just a minute. Give me a minute, please. Ma'am, am I audible now? Is my voice clear?
Yes, it's clear now.
So, shall I continue?
Okay, please.
Yes, please.
That is all the hardware. The things which you can touch, all those are called hardware. And one more name for hardware devices is called peripheral device. Right? So, hardware or peripheral device. Now, how this hardware is working? How does it listen to your instruction? So, those instructions are called programs. Those instructions are called your software. Somewhere you give the instruction, and based on that instruction, the hardware will work. That is called the programs, the software. Right? When you combine these two things, when the system is doing some computational work, That is, computer is basically the calculation, the max. Without max, the computer cannot work. So that is why it is also famous for computational thinking, where all the workings is done only through the calculation. Right? So that is why I have given a very simple definition, where a computer system is the one which combines the physical components and programs to process data. Right? It processes the data and it gives you some information. Now, if you see the diagram, what is data which doesn't have any meaning? For example, I'll tell you, when I say number 5 or number 6, you all will understand it is a number, it is a digit. But what it is, what I'm coming to say through 6, is it roll number 6, or is that 6 mentioning something? Right? When I say roll number 6, that becomes the information. That means data is raw. When it gives some meaning, that becomes the information. The same way, what the computer does is, excuse me, we are giving the data, it will process, and it will give you the meaningful information. Right? So one real time example which I have given is, as I told, we can type the marks. Right? So English, the particular student has got 99. Maths, the particular student has got 98. Right? So when we type the marks, the computer gets the marks from you, it will add up all the marks, and the total is displayed on the screen. So it is getting the data, it is processing, and then the result is displayed. Now, where this input is given, through which device the input is given, how the CPU is processing it, how the information is delivered, that is what we are going to proceed with the further slides. Yes, so this is your basic computer organization. That is the outline, the entire diagram, the detailed diagram we cannot show you, but the outline, this is how the computer is. That is what I have mentioned in the type of flow chart. Right? So even if one unit is missing out of this, definitely the computer cannot work. That is why the whole thing is combined and it will work. So it is called a system. Right? All the physical components, all the software combined together, and it will give you the result. Now we will just discuss the different units one by one. Now, first unit is input unit, through which you are giving the data to the computer. Now, for example, when I am typing something in the keyboard, so that means the keyboard becomes my input unit. When I am selecting the files through the mouse, so when I double click or when I click the mouse, some operation is happening inside the computer, right? So when I start giving the instructions, that is called input unit. Now, after I give the data, where does this data goes? Everything goes to the memory. So from the memory only you can access the data. From the memory only, even the system is doing all the type of process. Right? And next is your CPU. In CPU, there are three main things. One is CU, which is known as control unit. The second one is ALU, which is arithmetic and logic unit. And the third one is registers. So I will be also explaining you about these each unit one by one in detail. Now all the processes done in CPU. That is why the CPU is called the brain of the computer. Without the CPU, that is without central processing unit, the computer cannot work. Without a brain, a human cannot process, right? A human cannot do any work. A human is nothing without the brain. The same way, the CPU is the brain of the computer. After processing, what happens? Again, the output is displayed in the output unit. For example, now I am showing you the presentation which I have prepared. So you are seeing it through the screen. So that screen becomes your output unit. For example, you are hearing the songs, right? The speakers becomes your output unit. Whereas when you're speaking something through the mic, so the mic is getting your voice inside. So the mic becomes the input unit and the speakers becomes the output unit, right? So the instructions through which it is passed are called input unit, and the data which is shown in front of your eyes, or if you are hearing something through the devices, those are called output unit, right? Next, coming to the input unit. So I gave you some examples, right? We are using the keyboard to type the text, the mouse to select, scanner. You would have used the scanner, right? You will just keep the paper and you will just scan, which will be converted into PDF or image. So what happens? You are giving the input and the same thing is scanned and it is stored in your computer, which is later visible in your output device. So scanner becomes the input unit. Next, coming to your microphone, as I told you, it captures sound. That means it is getting the input from you. The same with webcam, it captures your image. Next, touchscreen. Touchscreen comes both under input unit and output unit. Reason, in the touchscreen, it accepts the input and the same screen is the one which shows you the output too, right? So it comes under both input unit and output unit. Next, coming to the output unit. As I told you, the monitor which displays everything becomes your output unit. The printer which produces your hard copy becomes the output unit, right? Speakers, projector, headphones, all these are called output units. Yes. Now, as I told you, the CPU, the brain of the computer. Now in CPU, I told there are 3 units. So all these 3 units are very important for CPU. Even if there is any error in one unit also, the whole system will end up in the error. Right? So the first one is arithmetic and logical unit. What do you mean by arithmetic unit? So, for example, we would have learned about arithmetic operations, right? Addition, subtraction, multiplication, division. All these are called arithmetic operations. Now, when we are coming to logical operations, what is logical operation? For example, when I ask you a logical question, is 50 greater than 40? So at that time, you're not doing any calculation, but you're thinking logically. Yes. So this comparison, all these things are done in ALU, that is arithmetic and logic unit. Next, coming to control unit. What is this control unit? So I told you we are giving the input through the keyboard. Yes. So when an input is given, this input has to reach the CPU. And in CPU, we have different types of memory we will be discussing now. So from the memory, again, it has to reach to the processor. For example, ALU is the one which is doing all the process. Then again, it has to move to the registers. I'll tell you what is registers. Or it has to move to the output units. I gave you examples of output units like printer, monitor, etc. Right? Now, the data has to move from one place to another place. Right? Now, who will take care of all these things? It is called control unit. It is like a traffic controller. The traffic controller, what does the person do? The person says, move this side, move that side, right? He will clear all the traffics. All these things are done by the control unit. So all these things are also done within a fraction of second. It will not take much of second. You would have seen how fast the computer works. But all these components are existing inside the processor. That is why it is doing all its work within a fraction of second. Next, what is registers? So as I have mentioned, it is very small memory, but it holds immediate instruction. So for example, let's say I have 5 operations to complete. 5 plus 10, 10 into 10, 10 divided by 5. Like this, I have some 5 operations, right? In registers itself, we have different types. We have data register, we have address register, like that, we have different types of registers. But now I'll tell you what is the outline of the register. So let's say the first operation is carried out by ALU. Now what happens? Now the second operation will be ready in the registers. Once this ALU has completed its work, now the control unit, what it does? Registers and it will put into ALU. Right? So that is why the word is mentioned, holds immediate data and instruction. What is the next instruction or what is the next task has to be done? It will be held in the registers. So these three things, that is ALU, control unit, and in general we say memory, right? But the specific memory is the register. These three parts are very important for CPU. Yes, so that is why it is called the brain of the computer. So next, as I told you, what is ALU? Now you all know the computer calculates, the computer thinks, the computer makes decision, but based on what does it make decision? Based on what does it makes the process? It is based on the arithmetic operations and logical operations. So as I told you, arithmetic operations means the addition, subtraction, multiplication, division. We have so many calculations apart from this. When we are going through coding and all, you will understand. We have floor division, we have modulus, right? So all these things comes under arithmetic operation. Now, what is logical operations? So based on this logical operation only, it will take some decisions, right? So how will this logical operations be carried out? Using this greater than, less than, equal to, and there are three concepts called and, or, not, right? So we all know what is greater than, we all know what is less than. What is this and or not? And or not is relevant to your addition, subtraction, and inversion. But what output you will get through and or not is only true or false. For example, and means it is multiplication. Not means it is inversion. Fine. So in and what happens? The computer will check whether both the conditions are true or false. Okay. Or means if any one condition is true, the computer will take it as true. Condition is false, then the computer will consider it as false. Right? The same way and or even not. In the next class, what I'll be doing is I'll be showing you the truth table. That is based on the output only, based on the output of and or not only, the computer will take the decision. Right? Now I am just showing you the outline. What are the arithmetic operations? What are the logical operations? Yes. Now, for example, I have given if A is equal to 25 and B is equal to 15. So I have given value for A and B. What will be A plus B? It is 40. So this is called arithmetic operation. Now, when I'm using the greater than or less than symbol or comparison symbol, that is called logical operations. Please note down these two things alone. In further classes, we'll be discussing the same concept in detail, and that too we will have some mathematical workouts, right? Yes. Now coming to control unit. So what does this control unit do? As I told you, if we are standing in front of a place, if a person is coming and guiding us or taking us to a particular place, so that is the job of control unit. When you enter the data doesn't know through which cable or to which place it has to reach. Okay. So now what this control unit does, first it will fetch the instructions from the user. It interprets the instruction. I told you, no, the arithmetic is different, the logical is different. All these are called instruction. When you are saying 5 plus 5, that means you are instructing the computer to add. How? Through the plus sign. Okay. Next, directs other components and also maintains the sequence of operations. So at a time, you will be giving 4 to 5 instructions to the computer. Now, which operation has to be done first? That is also is taken care of control unit. Next, I have given you a very simple example to understand. So a traffic police officer controls the flow of traffic and coordinates movement. So as I told you before. Yes, so this is the working of control unit. Next is very important part of a computer. There are two types of memory. One is primary memory and the second one is secondary memory, right? So the memory which is present inside the computer is called the primary memory. The how to say, the devices which we are using to store the data or to keep a backup, those devices are called secondary storage devices. Okay, I'm repeating again. There are two different types of memory in the computer. One is primary memory, which is already present inside the computer to perform certain tasks, and the secondary memory, which is used by the human, which is decided by us. For example, even your pen drive becomes the secondary memory, right? So the data stays permanent over there. The CD, the DVD, all these devices are called secondary storage devices. Now coming back to the primary memory. So in primary memory, the first type of memory which we are going to discuss is called RAM. The full form of RAM is random access memory. So the name somewhere it defines it. When I explain you what is RAM, you will understand why this is called random access memory, right? So as I mentioned here, it is the temporary working memory used by the programs currently in use. Okay. So why I'm mentioning it as temporary is, for example, most of you would have had or would have faced this situation. I will be opening a Word document and I have started typing. No, because when I open a Word document, that document will be residing in the random access memory, that is called RAM, right? So that is why it is called temporary working memory. At that instant, If you are opening any application, what happens from the secondary storage? It will be coming to your RAM. So from the RAM only, you will be able to access your data.
Ma'am, your voice
Sorry,
is not
any
clear.
doubts?
Breaking. Your voice is breaking.
Still
ma'am.
my
Your
voice is not clear.
Your voice is not
I
clear.
don't know,
Can you
for
tell
me
me
or
one
for
more?
all of you guys.
Sometimes your voice are bugging. Okay.
Is it happened now or right from the beginning my voice is breaking?
When you started to explain
Is my
RAM,
voice
random
cracking from
access
the
memory.
beginning?
No. See, when you started to explain about the RAM, okay, from there onwards.
Hmm. Okay. Okay. Am I audible now?
Yes, ma'am, audible.
Yes.
Explain random access memory again. So as I told you, there are two types of memory in our computer, right? One is primary memory and another one is secondary memory. So what is this primary memory? The primary memory is the one which resides inside our computer to do certain work. So all those work only we are going to discuss it. Now what is secondary devices? Secondary devices, as I told you, if you are using certain storage device in order to store the data or in order to keep the backup, so those devices are called secondary storage devices. Now, for example, when I say CD, DVD, pen drive, all these are called secondary storage devices. Right? Now, coming back to the primary memory, I told these memory are residing inside the computer. In that, the first type is called random access memory. Right? Here, if you see, you can understand I have mentioned it as temporary. Why this temporary is the random access memory store any data permanently. For example, if I'm opening a PowerPoint presentation, now for example, I'm showing you the presentation. I have saved this in my secondary storage device, right? But when I opened, where this presentation will be, this presentation at present, it is residing in my random access memory, that is RAM. Okay. Now, one more example, what I can give you is, let's say, for example, I am opening a Word document and I have started typing 5 to 10 lines. Now, there is a sudden power cut, right? And I don't have any power backup. So what happens? My system will be off and the data which I was typing in the Word document will be lost. Yes. So now again I can not retain it from my memory. What is the reason? Because my Word document was present in the random access memory. Okay. So random access memory is not permanent, it is temporary. So that is why it has one more name called it is a volatile memory. Okay, data is lost when the power is switched off. That is called RAM. And the next one is fast and temporary. When compared to the secondary storage, other devices, RAM is fast, but it is temporary. It can hold the data at that point of instant, but it cannot save the permanent changes. Okay. Now, how can you relate this with a real time example is, so for example, you are studying something. So what you will do, you will open that particular textbook you will read and you will close it, right? So at that time instant, what you are reading, which chapter you are reading, only that you will be opening and you will read it, right? So that is also one example of RAM, random access memory. Okay. So one more example related to a computer, what I can give is, you have opened a presentation. Okay, we will do this, right? We will open a Word document. At the same time, we will play music in the computer also. Yes. So what happens? Both the things will be loaded into your RAM. That is why when we are buying the mobile phones and all, what happens? We are seeing whether the RAM memory is more than 16 GB. That too, people who are preferring to play games, you prefer the RAM memory should be more. Why? Because the data, the whole lot of data is loaded into your RAM. Now, only when the RAM can occupy more data, then only your devices will be fast. That is why we people are focusing on the increased size of RAM. Okay, even 4 GB RAM, the mobile phone will work. Even 8 GB RAM, the mobile phone will work. But still, why we are trying to expand our RAM? The reason is we need our system to work quickly, work fastly. That is why the RAM space is extended. Next, ROM, read only memory, as the name specifies. So random, what did I told? Whatever application you access, immediately it will come to the RAM memory. So you can access the data randomly. The data which you are accessing randomly will come to random access memory. Now what this read only memory will do? This also comes under primary memory only. But the main difference between RAM and ROM is this is non-volatile memory. So as I told, volatile means it is temporary, whereas non-volatile means it is permanent. But since the memory is read-only, that means you can take the data out from it, but you cannot put your data inside that. Yes. For example, you are opening an Excel sheet, you are typing the data, then finally what happens? You save the Excel sheet. So that means you are writing the data into the memory. So in read-only memory, what happens? You can start reading the data from the memory, but you cannot put all your personal data into it. That means why this memory is used? It is mainly used to store your operating system, right? All the system related software which need not be edited, which is useful for your computer to operate, all those programs, all those software are inside this read-only memory. The best example which I gave is the operating system. Now, where this operating system, in which memory does it reside? It resides in your read-only memory. Okay. Now here you can easily remember this word. So RAM is your working space and ROM is your permanent startup instructions. Yes. A quick comparison in this table I have given. So as I told you, when the power is off, the data in the RAM is lost, but whereas in the ROM, the data is always retained. So you people know, right? When you switch off the system, the data which you have typed will be deleted. But does the operating system goes off? No, the operating system is there in your system only, right? So that is why the data is retained. Now, what is the nature of RAM? It is volatile. That means it is temporary. The data will be lost if the power goes off. But whereas in the ROM, it is non-volatile. That means it is permanent. Now, what is the main role of the RAM? It holds the current work, whereas the ROM, It stores all the permanent instructions and the firmware. Next, coming to RAM, as I told you, suppose if you are opening 2 to 3 files, all those are currently running files. So all those will be stored in, it doesn't store, it will reside in RAM. But whereas in ROM, what happens? All the startup and embedded instruction, basic input output service, that is BIOS. Immediately when you switch on the computer, BIOS, basic input output service, is the first software to run. Where this BIOS will exist, it will exist in read only memory, right? Okay. Now coming to the next component of the computer is hardware and software. Now what is hardware? As I told you, when you can touch things physically, that becomes your hardware. Whereas what is software? It is a set of instructions given to the computer. Now keeping only the hardware, does a computer work? Only when we have a monitor can you work. You can't even switch it on. When only you have CPU, can you work? No. There should be some coding inside your processor. Only then you can switch it on the CPU. When you have mouse, so you cannot work. You need some instructions. Only then the mouse will work. Okay. So I have mentioned here parts that you can touch is called hardware. So for example, keyboard, all the storage devices, RAM, ROM and all, they are hardware where we can touch. Now coming to programs and instructions, where we cannot touch, but through that the hardware will work. So all those are called software. So for example, you would have used Google Chrome, your Microsoft Word, your VLC player, your Python programming window, all these comes under software. Yes. Okay. This is very important now. Two broad categories commonly introduced. I wanted to introduce the system software and the application software. Now, what is system software? It is the instruction which is already stored in your computer, without which the computer cannot definitely work. Right? For example, the operating system will come under the system software. Right? Next, coming to device drivers. You all know, right? For example, if I have a computer, I will attach my keyboard, I will attach my mouse to the computer. Now, computer is just still a machine. How will it understand that I have attached a keyboard to it? How it will understand that I have attached a mouse to it? How will it understand that my computer has been attached with the speakers? It can understand through this device drivers only. Okay, so device drivers is a software which tells the computer that which device has been connected to your computer. Only through the device driver the computer can understand, okay, these are the devices which has been attached to me. Right? Sometimes we fix printers to it, right? So exactly it will know where this output should be sent. It will not send the printer to the keyboard. No, it will send the printouts to the printer only. How it is doing the job correctly? Because it understands the printer. This is the speaker. So that means the speaker will be getting only this type of output. So correctly it will send through the speakers, all your audios, videos and all. So what about the printer? The hard copy. Okay, so how the computer is understanding the different types of inputs and output devices attached to it? It is through the device driver, right? Now coming to the application software. Now, apart from system software, why do we need this application software? Is as I told you, in order to manage your hardware parts, this system software is used. Now, for example, if you want to do a presentation, I cannot use operating system. I need some other software, right? So there I'm installing the PowerPoint, the MS Word, right? If I want to hear some songs, I'm installing the VLC. Yes, if I want to browse something, surf something, I need the Google Chrome. I need the Edge, Microsoft Edge, right? So here the user is selecting what type of software does the computer need. That is called application software. Okay. So in application software itself, we have two types. One is general purpose and another one is specific type of software. For example, if I'm opening the Microsoft Word, you are also opening the Microsoft Word. For both of us, it is doing the same job. Yes. So this is called general purpose software. Right? Now, for example, let's say I have a grocery shop. Now, I need to install a software for the grocery shop. You are working in a bank, let's say in a bank. You also need a software to store the data, to do all the sort of calculations. Now, here what happens, being in the grocery shop, being in the bank, you cannot use the same software, right? That is, the software need to be customized according to me and according to your needs. Yes, so this is called specific purpose software. One is general software, another one is specific purpose software. Right? This is about the types of software. Okay. Now coming to the system software, as I told you, the software which is mandatorily required to work with the computer is called system software. So operating system is one example which I gave you. Now this is the outline how the operating system is working. So what happens? For example, if you want to take out a file from a memory, what are the process happening? See, first one, you are clicking on the file. Next, once the instruction is received, what the system software does, it will find the file from your location. Okay. And as I told you, it will load all the data. So what happens? Actually, it is a vast part, but I'm just telling you in short. When you are storing the data inside the computer, you all know it is not directly storing A, B, C, D into it, right? The computer can understand only binary language. So the binary bytes, that is in the form of bytes only, it will be stored in the memory. So what happens? This operating system loads all the data, okay, and then the hardware executes. That is, it will display in the monitor. Okay. So that is why the system software is the one which helps us to communicate with the hardware. Coming to the software, I have given one example of each software. So for documents, you can use MS Word. For presentation, by default, we go to PowerPoint. For web browsing, we use Chrome. For programming, we go for Python. Image editing, we have so many softwares, right? So these are extra software. We are using it, which is called application software. So here, what do you note is, without the system software, the computer cannot work. But whereas without the application software, the computer can work. The thing is, it cannot do a specific task. That's it. Now, suppose if I don't have a PowerPoint presentation in my system, and if I'm trying to create a PowerPoint, it will not work because that particular software, that particular instruction is not there in your computer. But when you have system software, the computer will switch on. Okay. So certain basic things will work. But when you need a specific software, when you need a specific task to be completed, that means you need an application software. So system software is mandatory, where the system cannot work without the system software, but the application software is not mandatory. Based on your requirement, you can install the application software, right? So in general, how does a computer work? So right from the beginning, I wanted to just give you a conclusion, right? So for example, let's say we are giving 25 plus 15. Okay, so that means what happens? We are opening a calculator now. What did I tell you? When you are opening a software, immediately that software will load into your RAM, right? So I'm opening a calculator. Through the keyboard, I'm giving the input and the data is in the RAM now, right? Now, as I told you, the CU will take the charge. Now it will bring 25, then it will bring the instruction that is plus. Now it will bring the next number 15, right? And it has brought everything into ALU now. Now what this ALU is doing, as I told you, ALU means arithmetic and logic unit. So since it is an arithmetic operation, now ALU is doing its job. It calculates the answer as 40 and finally it is displayed in your monitor. This is the simple outline to know how your computer is working. Yes. Now, can you all just match? This is just a small quiz. In order to make this session interactive, I have made this. Though it is simple, you can just start conversing. So, what does the keyboard do? You can choose the answer out of
It's a
these
data
5
entry.
boxes.
It's a entry data.
Very good.
Enter the data.
Yes. What about ALU?
It's arithmetic logic unit.
Performs calculations. For
Performance
Very good. It is
calculations.
number 4. It performs calculations. What is C? RAM.
RAM is random access memory, madam.
Random access memory.
Good.
the
What
fifth
does
one,
it do?
temporary working memory.
Permanent
Fifth one.
startup instruction.
Sorry?
Temporary working memory.
Very good. It is number 5. Temporary working memory. What is ROM?
ROM is read-only memory, madam.
Good. And
It's
where do
inbuilt.
you match with that?
It's inbuilt. It's in the processor,
Permanent
madam.
startup
It's in the
instructions.
processor. It's a
Is
processing
it number
cell.
1 or 2? Match. It is number 1 or 2?
Number
Permanent
one.
startup instruction number 1, madam.
Yes.
One.
Yes, it is permanent startup instruction. Monitor?
Is a display processed information number 2.
Yes. Yes. Okay. Okay. Again, I just wanted to give you a short quiz without any option, right?
It's
Which
keyboard,
unit
madam.
is
Number
used
1
to
is
enter data? Number 1 is keyboard. Good.
Keyboard.
Number 2?
Number 2 is central processing unit. Is a processor, madam.
ALU.
I want a specific answer.
It's a RAM, madam.
No.
ALU. ALU.
Very good. It is ALU. Good. Which memory is volatile? Question number 3.
RAM.
RAM.
RAM. Good. Which software manages computer hardware?
It is ROM, madam.
ROM.
Windows?
I told you there are 2 types of software, right? System and
Operating software.
application software. Now, out of these, which software? Actually, ROM is the memory device. Not.
Operating software.
Operating software.
Yes, it is the operating system which comes under system software.
Yeah.
Question number 5. Which is an application software? Can you all give me one example of application software?
Microsoft Word.
PowerPoint.
Yes. Microsoft Word, PowerPoint, everything. Yes, I have given you the answer. Yes. Okay. So for revision purpose, I'll be sharing this PowerPoint with you. In order to just do a revision, you can go through this. last slide. Okay. Thank you all. Hope this content was really useful to you. We will be further moving with the advanced concepts after this class. I just wanted to show you all the hardware parts and the software. So from the next class onwards, we would be concentrating more on the software, more on coding. And in case even if you want me to take any other specific topics, you can very well inform to Eduving so that I can prepare accordingly and I'll be teaching you.
Thank you.